Hey, QED coders. This is Michael. I am a director of improving. Yes, I am a director of consulting and improving, and I would love to show you the progress that we've been making on this demonstration of Janaga in a distributed system as part of an enterprise application. That here we are, simulating a university. So the last time that we met, there was a problem with Elasticsearch. We were not able to index things into the search index, and that's because we were blasting a whole bunch of things at it all at the same time. So I've been working on a fix. I've also been working on some extra observability features. So I want to show you what we have accomplished. I'll keep the video. I'll keep on Discord for a bit. See if somebody's going to join us. If you want to join us on Discord, go to immutablearchitecture.com, and there you'll find a link to get an invitation to join our Discord and hang out with us every Thursday at 1400. Daylight savings is coming up, so it's going to be 1300 in just a little bit. But we love to talk about modeling software, especially using immutable runtimes like Janaga. So let's remind ourselves where exactly we are. So first of all, if you want to follow along, go to github.com/janaga/university-system, and that will take you to this demonstration. Two places where you want to get started with the demonstration. You'll see a link right here to the university system model, which is expressed in a polyglot notebook. So you can download this this notebook and run it inside of Visual Studio Code and see what this university system is all about. So we won't be going through that part today. What we will be doing instead is we will be using Docker Compose in order to bring up a set of components that are all working together to make information flow through a Janaga mesh. So you go to the mesh, Docker Compose, pull all the images, Docker Compose up, -d build, and that builds and starts up all of the containers. Among those containers, you will find things like Jaeger and Grafana. So these things, and Prometheus is in there as well, although we're not yet to the point where we can really look at our metrics. But once we get there, Prometheus is going to be very, very handy. Where we left off last time, we just had an error trying to get SQLite set up. So this is not the Elasticsearch error that we were looking at, but we had this issue with SQLite. Let me yeah. So the problem, as it turns out, was that the path that I was using in order to set up SQLite included a file. Let me go to Janaga client factory. There we go. So this is an example of the code that we were running last time, although I've added one more thing right here, because as it turns out, the university importer is the name of this application, and I also had it inside of just application data, not local application data. So it was trying to build a path right through a file. Can't do that. So in order to help future generations, I have now augmented that error message. So it'll tell you this is a file, not a directory. And then that will help future me primarily when I do a demo and things aren't working. Oh, yeah, it'll tell me. So now we've got that resolved, and so we should be able to use SQLite on each of the different applications to store a persistent replica. And that's going to help with queuing behavior and with resiliency and being able to batch things up. Now, as I then observed, the behavior was not as improved as I thought that it would be, but at least now I can observe it. And the reason is that the new the new image for the replicator, now it's at 340, that new image includes OpenTelemetry. So we can set the OTel exporter OTLP endpoint to the collector and then set the service name. And then voila, it's sending all of its telemetry data. That's traces, that's logs, and that is metrics, all going to this collector so that it could be partitioned out and sent around to the various visualizers like Jaeger, Prometheus, and Grafana. Loki is a little storage component. So we have that all set up and ready to go. All I need to do now is run it. So let's docker compose up -d to disconnect --build. Even though I just did the build, it'll say, yep, it's built. And then it has to recreate everything that has been reconfigured, stop the things that depend upon those things that are being recreated, like the backend replicator, stop that one. There's a new image. Let's pull that image. Well, I already did the docker compose pull, so it's got that new image. And everything is recreated. Everything is starting up. And if we did our jobs correctly, everything should still be started. And indeed, they are. Excellent. Well, let's take a look now at what our behavior is. So, yes, okay, I gotcha. Let me go ahead and turn on this auto refresh here. So every 5 seconds it'll check for new logs, which will be very helpful. And now I can see we are getting some stuff flowing through. So this is the backend replicator. It is throwing out its own logs now. We can see those. We've got the indexer, we've got the importer, and they are all doing their things. So this is the error that we started off with, and now you can see that it started successfully and it is waiting for work to do. Meanwhile, the backend replicator has connected to its Postgres database and it is happily waiting. So there's this problem right here. Here's a little preview. Duplicate key retrying. What was the duplicate key? We have a duplicate key value violates uniqueness constraint UX fact type. Actually, that one is not a problem. That one resolves. But there's another one that doesn't resolve. And so we are going to, in a later iteration, fix some of these duplicate key violations, make sure that they happen less frequently. And when they do happen, they resolve. But that's not the problem that we are facing right now. The problem that we are facing right now is that we are blasting a whole bunch of things to Elasticsearch, and it is unable to keep up. So I have fixed that issue. Let me show you the new behavior that we receive. And just to make sure that it actually does re-index every time and doesn't see, oh, I've already done this work, I am going to modify the importer right here, the CSV file watcher. When it brings in a record, you will see right here it's creating an offering with a new good, as opposed to record dot offering good. And so that is going to make sure that every time we import data, it looks brand new. With the way that it would work in production code, record dot offering good, that would make it consistent. That would make it not consistent, deterministic. That's the word. That means that every time you run it, it's like, I'm going to do the same thing. And if it's deterministic, then Jnaga makes it idempotent. Those two things are very important. And so, Jnaga will see, oh, I've already got that fact. I don't need to do anything more. I don't even need to notify the indexer because it already knows. And so by creating a new GUID, we break that determinism, which then means that it's not going to hit that idempotency check. It's going to go through to the indexer every time, which means that I can take a whole bunch of data, wonk, and I can drop it here, and it's going to process that. And while it does, we are going to see, let's see here. Yeah, here we go. We are starting to see a whole bunch of stuff. It's importing all of these courses, and we are doing some indexing. So now, with this is doing this bulk indexing. So this is, you see a whole bunch of green. It is succeeding in doing that indexing, as opposed to what it was doing before, trying to hit the Elasticsearch server with a whole bunch of requests all at the same time. And Elasticsearch was like, nope, I'm going to fail that. You're going to have to retry. But now it appears to, oh, snap. Oh, snap. I was just about to say it appears to work. All right. Well, it looks like everything behind the scenes is working. But let's take a look at the indexer here. In fact, let me go ahead and refresh so that we can see all of the services available. We've got the indexer, we've got the importer, and we've got the backend replicator as a service that we can observe. But let's take a look at the indexer. So we've got these various traces that have occurred throughout the last few minutes. There's this one up here that took a long time. This took just a little bit of time, and we are way down here now with these traces that finish in picoseconds. I mean, come on. It just wakes up and says, I got nothing to do, goes back to sleep. Let's look at the second most interesting one here. Boink. And what do we see that it did? So we've got our indexer. It's indexing offerings. So it is then doing a bulk index records call. By the way, this the way that you can read these things, let me zoom in a little bit so we can see it. Whoa. See it a little bit better. Okay. So the way you can read these things, you see this black bar inside of the span. This is critical path. Basically, that means that it is running inside of this span. It is not awaiting another span. So that critical path is, it jumps basically to the lowest one. And so you can always find it's working in this function versus it's working in another function. So come back later. All right. Oh man, what is going on with this browser? Huh. All right. So we have done a whole bunch of work here. Here we have called bulk index records. What exactly is that? Well, let's take a look. We can see we're inside of University Indexer, and we're just doing some work inside of that process. If I take a look at some of the things that it calls out to, we've got get post. These look like HTTP calls, yes. So this is systemnet HTTP. It's creating its own little span and saying, I am calling Elasticsearch cluster health. I'm just checking the health of the cluster. And then reroute, figure out where I'm supposed to send my stuff. And then I can take a look at offerings settings, and I can see what is that index doing. But this one right here, this is the important one. Here we are calling the Elasticsearch bulk endpoint in order to send all of the information that we need to send to Elasticsearch all at once. So this completes in 14.5 milliseconds. Come on. Come on. Of course, it is all one machine. It's just different containers within this one machine, but come on. That's pretty good. So we make this bulk call, and that's a lot better than all these individual calls slamming Elasticsearch, and it's able to do all the work all at once, figure out what it needs to do, take its time. Its time is 14.5 milliseconds. But get that all done nice and efficiently. And then, now that we've got all that work done, we come back out here and we make another post. And this post goes to the backend replicator. I do a Janaga save. Foop. I'm going to save a whole bunch of facts to Janaga. And if you scan down a little bit, after we're finished with that, we do another post to the backend replicator, save another batch of facts, and then we save another batch of facts. So this batching up of the sets of facts that we're going to save, that is because we've got persistence on the importer side. So that means the process can store up its own facts and then do that batch. If it didn't have persistence, then that means that when you await fact.save or Janaga client.fact, it would have to get it all the way to the persistent store, which is in the replicator, before it resolved. Otherwise, it would have to throw an exception and let you know that, hey, I didn't save that. We're not going to just save things in memory and hope for the best. So saving it on disk, that's fine. So batch a whole bunch of things up, save them. Now you see the backend replicator took 48, so almost 100 milliseconds in order to do all of its work, and you can see a lot of work going on. So this can be optimized. That is one of the things that I absolutely love about being able to plumb this observability all the way into Janaga. Now I can see, oh, yes, in this scenario, in this context, we're doing all of this work. Maybe we can batch some of that up. We will work on that. Because I would love for this Janaga line to be as short as this Elasticsearch line. Wouldn't that be awesome? So we're, get the overhead of the replication down to about the same size as the overhead of the work. That would be cool. So that is just what we're looking at. But today we want to see, how did we get here? How did we get to this? Actually, this is the one line that I'm really interested in, which is really short. So how did we get to this bulk call? Let's walk through some code to see how we got there. All right, I am going to start with, we don't need the file watcher. We don't need the client factory. We are talking about the indexer, and we're going to start right up here at the program.cs, because why not? That's where we start. So if you recall, we see what environment variables we have, which ones we need. We log out everything that's missing, not just one at a time. We're not playing go fetch me a rock here. We want to help people set the whole thing up. So we've got all our environment variables, and then we start our telemetry. And then after we've got all that started up, we run this little console app. I don't know if I walked through the console app thing, but basically this is the thing that is waiting for the sig term or the sig int. And terminating the application. So it calls you back here at this async function. This async function returns a shutdown function. I got that pattern from React, and React. Oh goodness, what is that hook? Wow. React event? That's not right. Anyway, shout at me in the comments. What is that React hook that follows this pattern? But I borrowed that, and I said, this is a pattern I really like. So that's how I'm going to shut things down. Then here I've got this service runner. So I basically took all of those top-level specifications, and I moved each one down into its own little service. So now we've got this nice little pattern where we've got the offer index service and the offer time update service and the offer location update service. All these things that that updates the Elasticsearch based on a specification. Now you see I've got these last three commented out because I just wanted to focus on the offer index service right now. If I go into that one, you'll see this is what the pattern looks like. A whole bunch of dependency injection, and then we've got, here's our specification. That gives us all the work that we need to do, and then here's our subscription. This is what we do with it. That is the pattern. We can get rid of that, and then we can see the whole pattern all on one screen. You can see right here. It's returning a task completed task. It's not even async. It's not even awaiting. I made it possible with this this iService interface for you to do async stuff in here. But this one's not even taking advantage of it. It sets up a specification. It subscribes in that specification, and it says I've started. Nothing to await, which is pretty cool, I think. But let's take a look at this this particular service. So we've got our specification that is telling us what work we are looking for, and then the subscription is telling us how to respond to that work. The work that we are looking for are offerings, so successors of type offering in that semester, where there are no offering deletes, and there are no search index records already. So that's the bit that makes this specification act like a queue. Once there's a search index record, there's no more work to do. So this specification only returns the work that needs to be done. Then, once we've got those offerings that do need to be indexed, I go ahead and return that offering inside of this anonymous type here. But I also create a couple of, or three, observables. So I then further look for the times, locations, and instructors. And I keep those as observables. Now, you can see this instructor one is expanded out. So the others look kind of like this. So we've got the successors of type offering instructor, where there is no next instructor. So we're looking for the most recent one. And that is what you should return from that observable. These other two, by the way, are relations. So we defined a relation, and that's basically encapsulating that part of the specification into a property of the offering itself, so that I can do this kind of stuff. The reason that instructors doesn't follow that same pattern is because this goes down to the offering instructor and then back up to the instructor. So this is an entity relation, and these are mutable properties, if you've read the patterns in the book. So let's come back to here. And that gives us our times, our locations, our instructors. And now that we have subscribed to this specification, we are going to get called back with every projection that matches that specification. So that projection is going to have within it an offering. So I'll take my index queue and I will push the offering into the index queue. It says, I need you to index this. It's not awaiting it. It's not actually doing that right now. It's just pushing it into the queue, coming back immediately. And then I'm going to set up some callbacks. So let's take a look at the times. And here we go. So here we get an observable collection of offering time. When one of those offering times is added, then I push that offering time. Very good stuff. Do the same thing with the locations and with the instructors. So you can see these are offering instructors, not the instructors themselves. So all of that stuff is pushed into this index queue. Now here's that pattern again. Here is that pattern borrowed from React, where I return from the subscription a callback that is called whenever this offering no longer satisfies the specification. When would that happen? It'll happen when the offering is deleted. It'll also happen when there is a search index record. So this is the one that we're really interested in. When there's a search index record, that means that there's no more work to be done. The work has already been done. So let's remove it from the index queue. So now the index queue just contains the work that needs to be done. I need to index this offering with this time, this location, this instructor. That is the pattern there. Now, of course, pushing these things to a queue doesn't actually get the work done. Let's take a look at what we're doing inside of here. So given an offering, we can compute the record ID from that offering. And if you recall, that is just getting the hash and making it URL safe. There that code is again. And then once we've got that record ID, now we can lock and check our offerings collection. This is a dictionary, an immutable dictionary of offering index by string. Now we lock not because immutable data structures demand it, but because I want this check to be consistent with this add. So I lock around those two so that there's no interruption. By the time I get to this add, I know this offering does not contain the key. Without that lock, there could be another thread that comes in and whoop, adds the offering underneath me. So that's the purpose of that lock. Now that I've got that offering index in the dictionary, I can do other things, like when I want to push an offering location. I get the record ID from its offering predecessor, and then try to get that from the dictionary. If it's not there, I return. I say, well, I'm not sure how we got here, but hey, I don't have this this offering to update. So away it goes. And then I know that by the time I get here, I'm consistent, again, this lock, with this condition. So I know that the offering is in the collection. So I can just do a set item, and I can set it to a new offering index. So here's my offering index, and this is the old offering index, but now with the location set. And I've got a similar pattern for pushing the offering time and pushing the offering instructor. So what is this offering index thing? This is a record, an immutable object. So it's got an offering. It might have an offering location, it might have an offering time, and it might have an offering instructor. When we create one from the offering, it doesn't have those things, so we set those to null. But then when I say with location, then I'm going to replace this location here, but keep its existing time and instructor. Same thing with time, same thing with instructor. So I keep the the properties from its the prior immutable record, and I return a new immutable record that has those plus a little extra something. So with this, I am keeping track of, I'm using an immutable record to keep track of this, so that I can then put that immutable record inside of an immutable dictionary, and this index that I get out is everything that was in there before, plus this one little change. Now this thing with this record ID has a location. That's going to become important later. When is later? Well, later is right here. So after I've pushed the offering location, I'm going to start the index timer. So you can see I'm also starting the index timer if I do some other operation, but actually right here, push offering. This is the one that matters. This is the one that's really going to fire. So I'm pushing an offering. That means something has happened, and now I need to start a timer. What does that mean? Well, that means that if I don't already have a timer, I will start one, and it will tick every 5 seconds. And it's going to call index offerings. So now index offerings gets called, and what this means is that 5 seconds have elapsed from the first time that I started an index timer. So those 5 seconds have elapsed. Then what it's going to do is it's going to lock, it's going to grab the current offerings, and then check. Are there no offerings in that collection? If not, let's go ahead and stop the timer now. We're going to clear that out. We are no longer indexing. We are turning things off. So I lock because I want this to be consistent with this. So I'm just pulling that out of this offerings collection. But notice, if you've used this kind of pattern before, you might be thinking, oh, well, then I need to clear out offerings because now I've got these current offerings and I want that to be an empty collection to start collecting more things. But I'm not doing that this time. I am keeping this collection as it is, ready for others to do something with. So when I leave this lock, now the specification, that subscription, is free to add more things to that offerings dictionary. And that's perfectly fine. All I've done is I've grabbed a snapshot. And it's an immutable dictionary, so that's an immutable snapshot. And now I can leave that lock. I can do all of this work outside of that lock, which is pretty important because there's some async work happening here. And you can't await an async inside of a lock. If you were able to, you still wouldn't want to because you'd be holding that lock open for a long time. But here, we are leaving that lock. We have our snapshot, and we can start doing the work. So at this point, nothing has actually been indexed. So I haven't recorded any facts. I haven't done any bookkeeping. I'm not committing to anything. It's just I have some work to do. So now let's do that work. You can see a whole bunch of telemetry stuff. We're doing activities. We're doing stopwatches. I'm gonna abstract all this away and make it easier to read this. So all we really want to do is right here. We want to index many records. So go to Elasticsearch and index all of these search records. Where do these search records come from? They come from those current offerings, that immutable dictionary. But then I select, by key value pair here, the value.getSearchRecord, the key. So what does that mean? That means that I am inside of the offering index, so that's the object inside of the dictionary, and I'm passing in the record ID. That's the key. And I'm saying I want to get a search record. So I always have an offering. That one is not optional. That one's not nullable. But I might not have a time. I might not have an instructor. I might not have a location. So if I don't, then I use TBA for those properties. But if I do, I grab them from the facts that I have. So that gives me a complete search record that I want to index all at once. And this gets past the problem that we were seeing that last time. So the last time we were initially inserting something with TBAs all across the board, and then we were immediately coming back and trying to update that record that's already in there. Elasticsearch doesn't like that pattern. This is a much friendlier pattern. So I get all of those search records all at once, and then I index many records. That calls the bulk endpoint. We don't need to really dive into that. This isn't about Elasticsearch. This is about the batch pattern. So now that you've indexed all those search results, check to see if we've got any errors. If we do not have any errors, then we go through the offerings and we record these bookkeeping facts. So now I say that the search index record exists. So let's go ahead and create that for this offering and this record ID. And then if we have set the offering time, then I want to also say that the search index record time update exists. And so we've got this search index record that I just got back here, plus the index time. I say this is the value that was updated. And I do the same thing with the location. That's the location that was updated. Here's the instructor that was updated. And all these bookkeeping facts go into the model. And that's where I'm actually awaiting and saying, okay, all these facts. So this is where you saw Janaga client batching up a bunch of these facts and then sending them all to the replicator all at once, and then coming back, patching them all, sending them all. Which, as I described before, it can do because it's persisting this fact to SQLite on this node, on this container. So this await resolves as soon as it's saved. It doesn't have to wait for it to be sent. So save it, and then, okay, now we can send a batch. So that gives me my batching inside of Janaga. This gives me my batching inside of, where did it go? I got my search records right there. Index many records. That gives me my batching inside of Elasticsearch, and I've got much better behavior. We can get some stuff from the replicator, send it to Elasticsearch. We can get more stuff from the replicator, send more stuff to Elasticsearch. And this whole behavior here of only right here is indexing. I set is indexing to true. Once I have some stuff to do, and then when I'm done here, I set it to false. I'm still locking because I'm mutating a property of this object. So even though that's a Boolean, and one could argue that would be an atomic operation, it's a CLR Boolean. It's not like this is a bit in. I mean, eventually, of course, it is a bit in memory, but there's CLR stuff going on. Come on, be kind to the CLR. So yeah, this is saying, okay, I am finished indexing, and now you can let somebody else through. So there's only going to be one thread inside of index offerings at any given time, and that is going to keep that batch, pick this up, do that, pick this up, do that. Good, keep that nice and clean. So that is the pattern that that we can put it into place. Now you can see there's a whole lot of telemetry stuff kind of sprinkled sprinkled throughout this thing. A lot of noise going on. It's really hard for me to find the work to do through all of this telemetry stuff. And then right here, the bookkeeping. I want to see the bookkeeping. What I'm going to do with this, I'm going to clean it up. I'm going to bring those things out so you can see them a little bit better. And then we could actually take this one step further. So you can see, like here, all of these push. These are nice and small because I've already cleaned things up here. We're just doing immutable record operation kind of things. So I gave that a name so that we could just see that that's what we're doing. So that's nice and clean. But this still mixes some infrastructure knowledge and some domain knowledge. Some things that we could do to clean things up even more is to say this is a general pattern for indexing to Elasticsearch. We'll just start there. And then what I might want to do is parameterize this this object with a few things. Like, let's go ahead and parameterize it with this specification. Let's just say here is the specification for what I want to index into Elasticsearch. And then here I can say, and the way you do that is you compute the ID like this. Maybe even computing the ID is a given. It's the hash of this top level entity fact, and then this is how you map the properties, these mutable property facts, into these searchable elements of the search record. Pull all that knowledge out, and now this just becomes a way to configure Elasticsearch for this domain. Then all the details are down there. And then you can configure search for a different domain, and all the details are down there. So that would be a great next step. That would separate the infrastructure from the domain, which is a core tenet of Janaga. And then you could go even one step further and say, well, there's Elasticsearch, there's also OpenSearch, there's also Lucene, there's also all these other things. And so why don't we go ahead and turn that abstraction into an interface and let adapters figure out how we are actually realizing that search. And so now we can even pick and choose our search capabilities with just that interface. So that's ultimately where we're going to be taking this, and that's really going to make this a lot easier to read. And so now you just have this surface that says, here's what the work that I want to do, here's how I want to do it, and the thing that actually does it is abstracted away, and it's a search index, and it follows this interface. That is going to basically make, we get there. Each one of our microservices, this is smaller than a microservice, but each one of these services is so small, such a little tiny bit of work to do. So let's pop the stack one more level here. Let's come back to what we did was we set up this index service, and we started this whole service runner, which presumably could have multiple services in it. And we will take a look at those multiple services running together on a later iteration. But this package, this combined set of these little service objects, this is kind of the microservice boundary. So a microservice, the way that we usually talk about it, it does just one thing, and it's an independently deployable thing. In practice, it sometimes doesn't make sense to have an independently deployable thing that just does one specification. This one right now just does one specification, but it could be that yeah, when the time changes, coming back and updating that index, that's still part of the responsibility of this one microservice. So when I talk about microservice, I'm talking about the process boundary. This little iService implementation, that's even smaller than micro, and it's got maybe, I don't know, nano service. No, let's not do that. The idea is you can take each one of these, what's the work? How do I do the work? Each one of these things, you can package up a bunch of them that seem to make sense together. Like all of these need to touch Elasticsearch, so it makes sense for all of them to be in a thing that can access that one thing. But then the really cool part is that they don't talk to each other. Not directly. They all have a specification. And the work that they do ends up creating facts that are used by the other specifications. So the way that these communicate with one another is through the same specification that this process, this microservice, is using to communicate with the replicator. So it's the same pattern. Whether you put them all together and call it a monolith, or whether you break them apart and call them microservices, it's the same pattern. It's the same pattern. Oh God, I love that. Okay, so that is where we are with this thing. So we are getting some really good behavior here. I want to get better behavior here, but yeah, we've got some other ways some other improvements to make as well along the way. So I'm pretty excited about this. Please give it a try. Grab the repository, run it yourself, tweak it, play with it. Tell me what you think. Leave a comment and send me an email, michael@qdcode.com, michael.perry@improving.com. Let's figure this stuff out together. This has been fun. All right. Well, I will see you next week.